Okay, so we're going to be doing the transformation called dilations. Okay, with a dilation you need two things. You need a scale, and okay, it's called the scale factor, and you need a center of dilation. Okay, so usually we center it at the origin, so I'm going to dilate, okay, triangle ABC by a half, centered at 0, 0. Okay, so you're probably going to want to pause the video and get graph paper and graph this first, and then come back. Okay, welcome back. So I'm going to 0, 0. And what I'm going to do, I use the slope method, so I'm going to move from 0, 0 to B. So up 1, 2, 3, right 2. Do it again. Up 1, 2, 3, right 2. That moves B twice the distance away. Oh, I wanted to make the scale factor of a half. Sorry about that. Okay, so I'd have to go up 1, 2, 3, right 2. So instead of going up 3, right 2, I'm going to go up half of 3. So I'm going to go up 1.5, 1.5, and then I'm going to go right, instead of 2, right 1. So that's B prime. Okay, so for A, all right, so for A, I'd have to go up 1, left 1, 2, 3, 4, 5. So I'm going to go up a half and left 1, 2.5. That would be A prime. So all the points are being sucked in toward the origin. Okay, half the distance. And then let's take a look at C. So that's at -6, so that will be at -3. So that's C prime. Okay, things you need to know about a dilation. Okay, the perimeter is half, but the area is actually a quarter, because you have to square the scale factor. And a half times a half is a quarter. Okay, so the area of triangle A prime, B prime, C prime is 1/4 the area of triangle ABC. Okay, but the perimeters are equal. I mean, not equal. The perimeter, silly me, of triangle A prime, B prime, C prime is just a half the perimeter of triangle ABC. Okay, other things you need to know, there's usually multiple choice questions on these. So for instance, A prime, B prime is a half AB. Okay, the scale factor is an Italian job. IO, image over original. This formula will help you a lot. So the scale, we know the scale is 1/2, right? Well, 1/2 is the image, A prime, B prime, over AB. And you could always use the distance formula to check that. Okay, but then we can multiply this in any way, shape, or form. So another thing that would be true is 2 times A prime, B prime is equal to AB. See how I cross-multiplied? But if you know this formula, you could set it up and then cross-multiply accordingly, okay? Okay, in the second question, we're going to be dilating triangle ABC by a scale of 2, centered at 2, 3. So each point is going to move twice the distance away. So if I go from J, right, to B, I'd be going up 1, 2, 3, left 1. Do it again. 1, 2, 3, left 1. That shoots B twice the distance away. Okay, A, down 1, left 1, so down 1, left 1 again. So A prime. C, down 1, 2, right 1, 2, 3. Down 1, 2, right 1, 2, 3. So that would be C prime. All right, connect those up. You can see that the area is definitely more than double. The area will be quadruple. And the perimeter would be double. So whatever the scale factor is, you square that scale factor to get the scale factor for area. So the area of triangle A prime, B prime, C prime is double the area. I mean, not double, quadruple I meant, sorry. I'm thinking of perimeter for a second there, I don't know why. Quadruple the area of triangle ABC, and the perimeter is the same as the scale factor of triangle A prime, B prime, C prime is just double the perimeter of triangle ABC. Okay, in this third example, I'm going to be dilating segment AB by a scale of 2.5 centered at G. So if I start at G and go to A, I'd have to go up 1, 2, 3, 4, right, 1, 2. So to double it, I would go up 4 again, 1, 2, 3, 4, right, 2. But then I would go up just another 2 and right 1 to get 2.5. Because I moved half the amount up and half the amount right after I had already moved up and right, that was double. And then I did half of that amount, so that's 2.5. That's A prime. Okay, G to B, I'd be going down 1, 2, 3. Oh, down 2, sorry. Down 2, right, 1, 2, 3, 4. So I'm going to go down another 2, right, 1, 2, 3, 4. But then I'm going to go down half that amount, so down 1, and right, instead of 4, right 2. Okay, so this would be B double prime. Okay, connect those up. Now, seen a question on the Regents where they ask you, which of the following is true or always true, whatever. So there are things they could ask you, like, for instance, if I connected G to A, okay, remember the scale factor is image over original. So now I connect that to A prime. So for instance, they could have G A prime over GA, right, is 2. They could make this variation. They could cross multiply. They could flip it. So they could say GA over GA prime is 1/2. These are the types of things they could do. 2 times GA. All right, 2 times GA equals G prime A prime. Okay, things like that. Okay, one of the things you want to know about this is that these are parallel. So when the center of dilation, okay, is off of the segment and you get the image, you're going to end up with a parallel segment. Okay, this segment, if you use the distance formula, which you can pause and check it if you want. So the distance, A prime, why did I write B double prime there? Don't know. Okay, A prime, B prime. That distance is going to be 2.5 times the distance from A to B. Okay, and the distance from A to A prime is 1.5, okay, times G to A. So there are all sorts of things that they can ask you about this. So just keep that in mind. I can't predict that. Okay, the last thing you need to know about dilations is dilating a line. So let's say that I have the point of dilation on the line. So let's say I have 0, 2. Okay, I'm going to graph a function here. Okay, but I'm going to make 0, 2 the center of dilation. Okay, and I'm going to dilate, all right, line, whatever, we can call it AB, doesn't make a difference. Dilate AB by a scale factor of 2, okay, centered at 0, 2. Okay, and I have to give you the line. So let's make the line y equals 3x plus 2. Okay, pause the video, graph that line like you did last year. Okay, so what I did is I started at 0, 2, right? I went up 3, right 1, up 3, right 1, down 3, left 1. Okay, that generates a line. Okay, so this is the line y equals 3x plus 2. So I'm going to move all the points on the line twice the distance away from the center 0, 2. So what would happen is, okay, this is your center. Let me call the center G. So if I have point A, right, point A would just move twice the distance, but do you see that it would still be on the same line? Okay, point B would move twice the distance, 1, 2, 3, left 1. So point B prime, you can extend any line, would still be on your line as well. Okay, so you need to memorize that if you're dilating a line, so the image of a line with the center on the line is always the line itself. It doesn't matter if the points move on the line because they're still going to be glued to the line. Okay, you need to memorize that. Okay, so here I have the center of dilation off the line. So if I just use A and B, okay, and let's say I go from G to A, I'd be going down 1, 2, 3, 4, left 2. So I would repeat that. Down 1, 2, 3, 4, left 2. So that would be A prime. Now I'm going to do the same thing from G to B. So I'm going to go down 1, 2, right 1, 2, down 1, 2, right 1, 2, because I'm doubling it. So that's B prime. Now if I connect those up, make a line through them, what do I end up with? A parallel line, right? So you need to memorize, okay, when we dilate a line with the center of dilation off the line, okay, the image is a line parallel to the original line. All right, I hope this video helped, and we'll continue this in class. Thanks, guys.